Hello everyone, and welcome to another video. Now it is actually quite late, which is why the light kinda sucks and why I'm probably going to be a bit more silent, because I'm also tired. So, here we have again the GTX 780 Jetstream from Palette, and I've now decided to actually run it a bit. So you can see it had some modifications, nothing crazy, but I did have the card pull off some rather impressive scores and clocks. So if you're not familiar with this card, the story basically is I think before the 780 Ti was released, so somewhere in 2013, this was bought as part of a pre-build. It was then later removed from said pre-build and found its way into my sister's PC, who was, until beginning of this year, was dailying this card until I replaced it with my 980 Ti Strix, which she's now dailying. And yeah, after that I put it in a bit, found out, yeah, it does like 1240 core plus 500 memory, which basically brings it onto the same memory speed the stock 780 Ti comes with, but nothing more. Like, not really that impressive. The cooler was kinda good, and the PCB was pretty good. So I looked into the PCB and I was like, yeah, rather pleased with the VRM. So it basically is the reference VRM plus two phases. So you have an 8-phase V-core with 50 amp power stages or DR MOSes. I don't exactly know how smart they are. If you can call them power stages or just DR MOSes. They should be the same you get on the reference PCB. So yeah, this is not a super crazy PCB, but it's decent. Very decent, and it gets this nice heatsink baseplate. Like, this used to be a full baseplate, but I cut it in half because the memory section was interfering with any kind of custom cooler I was gonna put on here, so I just cut it in half, so I just keep the VRM section, and then memory is gonna have to be airflow cooled by a fan. And the heatsink is working rather well, even with some rather substantial overvolting. This stayed very, very cool. Like, you could touch this no problem. It was like 30, maybe 40 degrees at most. So yeah. So, in the beginning, I did not have voltage control on this card, as seen by the potentiometer. Now I do, obviously. So the controller of this is an NCP 4208, same controller I have on my 780 Ti Windforce. Here on the back, just a simple feedback mod, just a 50k ohm potentiometer, and yeah. Other mod I did is I removed the INA 3221 power monitoring chip, so this just doesn't have a power limit anymore, it's just gone completely. Then memory is yet unmodified, because it is one of these probably Richtech controllers that like the marking on that, if you Google it, you get nothing. You need like a data sheet from, I think only Richtech is doing this. And I have a list of codes. So there's a code on this. You need like a list how to decode that, and then you can find out what controller that is. Yeah, so that's why I don't have memory voltage control yet. I didn't bother yet. Then the next modification I made, I added some SMD capacitors. So this one, this one, this one, and this one. These three are on memory. This one is on core. These yellow ones are just from one of the 580 GTX 580 Zotac cards that I turned into an e-power. This tantalum is probably, maybe, I actually don't know what this is. This could be from my GTX 470 from ages and ages ago. On the front, one more tantalum, that's core. This one is not core or memory, so I left that empty. I actually don't know what that is. Could be 1 point like something, I don't know. It's next to the BIOS chip, so maybe it's 1.8 volts. I don't know. So yeah. So power limit is removed. It's gained some capacitors just because there were empty pads. The capacitors actually seem to have helped a bit. I haven't tested memory. I've basically only run core. I've run memory just at plus 500 all the time. So yeah, and then I added this volt mod. So, and then obviously I hooked up custom cooling. I've used my now old water loop, as I've basically not like I'm missing a radiator. Apart from that, I have a new water loop running. So the DDC alpha Q pump I had is going into the new loop. The old loop is just like the one you've seen, the 240mm rad, the CPU block I turned into a GPU block. Just that it now has a 15 euro AliExpress pump instead of the DDC. And the DDC is going together with a freeze mod GPU block, which has like a better fin structure. It has a jet plate, and I think I'm gonna show that one day. And a not yet arrived 360mm radiator. I don't know when this is coming. Everything else has arrived. I will probably have to pay like customs fees because it's over 20 euros. And as far as I know, everything going to Germany over 20 euros has like, I have to pay customs, and everything else was under 20 euros and has already arrived. So yeah. So once that radiator comes, I will have two working water loops. The new one hopefully being better performance, since it has a better block, a bigger radiator, and a pump that is made by a reputable manufacturer. Not to say the old loop is bad. So this on the old loop, so I opened my window and I used the very powerful 19 watt fan that I had. That's also very loud. And this actually went to like 27, 28 degrees max under load. So this ran pretty cool. Actually, this was getting close to ice water temps on the GTX 580 Direct CO2. So yeah, that just shows how bad I was back then because I was running the IHS. As to power consumption on this thing, I wasn't able to measure it, but I'm estimating between 350 and 400 watts going into the card. I mean, I can't measure it. The INA 3221 is gone. And yeah. So, voltage, I changed in steps. Ultimately, I ended at 1.3 volts behind the core, which was like 1.35-ish at the VRM. So this does drop a considerable amount of voltage, actually. Not that it's an issue, the VRM stayed very cool. So yeah, 1.3 volts behind the core, that's sort of where it's stopped scaling. I tried 1.4 at the VRM and 1.35 behind the core. That didn't get me another step for core clocks. So I guess 1.3 volts behind the core is where it's at. Haven't seen any scaling beyond that point. So I guess it's just gonna need more cooling now. Or more caps, maybe. So yeah. So what clocks did I actually run? Now, this is where it gets interesting, because like from the ASIC quality, this is a rather normal core. It has a better than 50% ASIC quality, which is, well, average. But the clocks that this is pulling off are actually very impressive. I haven't run, even though I I think I've straight up said the 780 Ti's are my favorite graphics card, and I think that's still kinda true. I haven't run them that much, like my Windforce. I really don't want to stress that much because I feel it's gonna die again. My Matrix I haven't done anything with because, well, it was kinda expensive and I wanted to gain some more experience before I abuse that one. And then my Zotac one, which is a reference PCB, well, it's a reference PCB, so it sucks. Though I did run the Zotac card on the Kingpin BIOS, which meant 1.3 volts at the VRM at least, so, well, guess 1.25 behind the core, and 1.25 behind the core, this one did significantly better than that card. So, with the caps alone, without a volt mod, this started doing 1280 now on the core, which, well, that's kinda good, but nothing really impressive. Then with 1.22 volts behind the core, which I actually have never bothered measuring stock, but I think it would have been around 1.15. behind the core. So at 1.22 this did around 1340 on the core, which is already, that's pretty good. Like over 1320 megahertz I consider pretty good. And 1.22 volts, that's not really that much. It's more than you will get in software control, but like it's still not a lot considering how high voltage you can go and how high I did go on this. So then I went some more steps until I eventually ended up at 1.3 volts behind the core, and at that point the card did a very impressive, in my opinion, 1437 core. So not only did it break 1400 megahertz, it actually went past that by almost 40 megahertz. Which, yeah, I've never gotten my 780 Ti's anywhere near that. Even considering that my WindForce and my Matrix have a better ASIC quality than this has. So yeah, again, proof that ASIC quality isn't exactly everything. This core absolutely loved getting overvolted up to 1.3 volts. And it obviously also really liked the cold from the cooling. So yeah, 1437 megahertz, that's quite something. And in terms of scores, so I ran Firestrike just because I ran Firestrike with everything. In terms of scores, this actually rivaled a 1.15 gigahertz-ish 780 Ti. Which, yeah, I don't know how daily stable that core clock would have been, but even getting to that territory, like essentially turning this into a 780 Ti from performance standpoint, that's pretty impressive, I think. And to that added is I was using some very old drivers. So my benchmark OS recently was corrupted. So I went up to a backup OS, which had very basic things on it, and it only had drivers for Fermi cards, so driver version 391 something, which is really old. So I probably ran with that driver, and it also had validation warnings and like the driver's not approved and stuff, and like it was auto installed by Windows. So yeah, that would have impacted the score. Then we also come to the part that I'm running a Ryzen 7 1800X. And I recently learned that first gen Ryzen apparently makes your GPU score just worse in 3D Mark. Which I also proved because the person I'm sending the 460 SoC to got a 780 Lightning, actually two 780 Lightnings I think. And he got higher scores out of his card with lower clocks across the board than I did. So yeah, my first gen Ryzen CPU is probably holding me back. I'm maybe looking into getting a better CPU then, because one person offered me to trade my 1800X for 3600, which I might do. Still thinking about that. I also don't know if they want extra money or something for that. But yeah, back to the card. So this did some really impressive core clocks, and even with all the handicaps I just listed, this still rivaled a 780 Ti that, well, 1.15 gigahertz, that's like what my 780 Ti WindForce ran stock. Which is, yeah, that's like custom 780 Ti territory, like you could overclock a reference card to that, but it wouldn't ship at that clock. So yeah, that's pretty nice, impressive of this card. And yeah, I haven't run Kepler enough to really say if this is like a good core or not, but I kind of feel like this is a good core. So yeah, I think I'll be running this more. Especially since there's some of these things, like, okay, I could unlock overcurrent protection, though I haven't tripped that one yet, and I do have like control over PLL and VRAM as well, so I actually don't need a datasheet for this, I just want voltage control. If they're hooked up, that is. Sometimes Pallet puts these things on cards and actually doesn't hook them up, but I think they are hooked up here. So yeah, like even PLL voltage means that like this thing is theoretically LN2 ready, or like meant to, like designed with LN2 in mind a bit by having these voltage controlled read points. And yeah, I mean the VRM, it's not the most powerful ever, but I think it would do LN2 fine. Like, yeah, it's been running really cool so far, and like not having issues. So yeah, this 780, I really like this card. Like, decent PCB, what seems to me like a really good core. Then well, the memory, it's Hynix AFR. I haven't really worked with that stuff. I don't know how well it responds to being overvolted. Hynix memory, in my experience, doesn't really like being overvolted, but I know of some Hynix memory that does like being overvolted. So it could be either things. It's just like in my past, I mostly worked with 1 gigabit AFR. This is 2 gigabit AFR. The name doesn't really mean anything. It's two different chips. But 1 gigabit AFR did not like being overvolted. So much so you overvolted, the card won't boot anymore. 2 gigabit AFR might be completely different, just like on DDR4. 4 gigabit AFR is kind of decent and 8 gigabit AFR sucks. So yeah, gonna have to find that out. I hope it does scale with voltage, because my Matrix 7970 also has 2 gigabit AFR. So I hope that one scales with voltage, because I do plan to run that card as well. But yeah, for now, I really like the results I've been getting with this one. And yeah, like I wanted to start working more with 28 nanometer cards. Because like I mean, I still like Fermi. Fermi is cheap. Fermi is awesome to work with. Like if you want to get into overclocking, I would very, very much suggest a Fermi card. But like I want to branch out a bit, and I have all these 28 nanometer cards with like big, like this is even bigger than a GF 110. So yeah, and so far I'm really liking my overclocking experience with this card. And yeah, I just hope that like getting proper drivers, getting the OS set up properly, maybe doing some more like volt mod for the memory. Maybe, well, volt modding core is not really that great. I could put some caps on the memory, but if these three didn't do anything, then, well, could basically put some multi-layer ceramics here, but that's gonna be a huge pain. So cap modding wise, this card is not that great. So as far as PCB modifications go, I don't think I'll be doing much here. I guess I'm just gonna try, like, yeah. Should just hope that the radiator is gonna arrive soon, so I get the new loop working. Maybe put memory voltage control. And yeah, then just see if I have some other tricks to pull off. But like the core, like 1437 megahertz, that's like way more than I was expecting to get out of this. So yeah, I have high hopes for the card actually. Like this might be a really, really good card. Like I mean the core could be a really, really good core. I don't know about the memory. If the memory is trash, that would be really, really bad. Like unfortunate. I would be kinda why is this core stuck with this memory? Like I really would have liked Samsung, but it's kind of interesting. It kind of seems like the region kind of dictates what sort of memory you get on your cards. So for 28 nanometer cards, I've basically seen only Hynix in my region. I've seen one Samsung card, which is my 670 for the win. That is Samsung. Every other 28 nanometer card, literally every other 28 nanometer card that's not super low power, which come with Alpida, had Hynix memory. And then for Fermi, it's the other way around, where there's just very few Hynix cards and a lot of Samsung cards. So yeah, I would have liked to have Samsung memory on this, because I know the Samsung memory you get on Kepler does scale with voltage and just goes really fast by itself, which I saw on my 670. but maybe 2 gigabit AFR is gonna be decent as well. I'm hoping for that. So yeah, last thing I think I could say about this is you might have noticed the very excessive amount of thermal paste on this core. This actually seems to help. So I once put on a bit too much thermal paste on my 580 direct CO2, so it squished out the sides like this. And I noticed the temps actually got like a lot better. And I know that if you're doing liquid nitrogen or dry ice, you do intentionally put on more thermal paste than you need to squish it out the sides, because that actually like helps with thermal transfer, because when your pot is so cold, the thermal paste around the die actually also helps with thermal transfer. And my working hypothesis for this is that, well, maybe it also helps at ambient, less so, but it might still help, which is probably why I was seeing the temperature difference on the 580 direct CO2. It might have been just a good mount, but I was seeing much better temps with just more thermal paste. So I put some more thermal paste around here, and you can see the core is still slightly higher than the rest of the thermal paste. Yeah, so I don't think it will actually do anything really. Like, I didn't really waste any thermal paste on this. All the thermal paste on here is actually scavenged from other things. I actually tend to reuse thermal paste a lot, and so far it hasn't really had any negative effects, though if I'm pushing for scores, I guess I should put new thermal paste because there's like things in it. But yeah, I'm not wasting any thermal paste, especially because it's kind of getting low. Like, I don't have much thermal paste left. So yeah, I don't want to waste any of it. But yeah, so this might help. I don't think it is, because the core is still slightly higher than the rest of it, but well, who knows? It's not like it's hurting the card. So yeah. So 780 Jetstream. Very, very impressive, actually. I expected much less out of this card, and I am positively surprised how well this has been doing. Like, the core seems to be really like pretty good. Now I actually want to run my 670 more. Like, yes, it's first gen Kepler, this is second gen, but like, it's still Kepler. Though I have seen some rather big scaling difference between GTX 400 and 500, which is first and second gen Fermi. So maybe the 670 is gonna do a lot different than this. But so far I can say that GK110s, at least this one, really likes being overvolted and it really likes being cold. So yeah, like over 1400 megahertz on a not really exceptional PCB on a core with not really exceptional ASIC quality, just a bunch of cooling and vCore. That's all I did, and some extra caps, but like, yeah, you could have just gotten a better PCB. So yeah, don't want to waste your time anymore. We are already at 23 minutes and about to be 24. So thank you for watching. Hope you enjoyed. I think you're gonna see this in action. And yeah, until next time, goodbye.